Hello friends, welcome back to NaniCodes. Today's daily Leetcode challenge question is string compression part 2. I totally agree. Today's question is a hard level question. Okay, let's discuss the question briefly. Run length encoding is a string compression method that works by replacing consecutive identical characters with concatenation of characters and number marking the count of characters. For example, to compress AABCC, we replace it with A2BC3 because A is repeating 2 times, so A2, and B is only 1 time. We just don't make any changes for B, and C is repeated 3 times in the given string, so we compress it as C3. So here they have given a notice point that we are not adding 1 after single characters. We can see that in this example, B is only repeated 1 time. He is not replacing B with B1. He is only represented it as B. So, okay, let's discuss this question using an example. We use whiteboard here. Okay, here we take this example, and the compressed version of this string is this A2 BC3. A is repeated 2 times, therefore A2, B is only 1, therefore it's still B, and C is repeated 3 times, therefore C3. So okay, now here comes the major part of the question, deleting the okay, now here come the major part of a question, that is deleting the utmost characters to get minimal possible string. Deleting the utmost characters for getting minimal possible string. That is, if we take these example A B C C C D, if the K is given as 2, this is the example given in the question itself. This one, this is a question. This is the example given in the question itself. Here K is 2, that is K represents the utmost characters to get deleted for getting minimal possible strings, a minimal possible string. So here what we do is we'll make a number of all possible solutions. So let's make hypothetical solution. Here we get A, B, C, 3D when we delete 2 A's. If 2 A's are deleted, we'll get A, B, C, 3, D as result, which is of length 5. And if we delete, okay, let me erase this one. Oh, sorry. Let it be. Okay. Now, if we delete B and D in the given string, then the following answer would be A3, C3. That is, if we'll change the color. If B and D is deleted, the following result will be A3, C3, and it is of length 4. It is of length 4. Now another possible solution is by deleting C and D. So if C and D is deleted, then we will get A3, B, C2, which is of length 5. Which is of length 5 again. And One more possible solution we can get out is by deleting both c's. Then we will remain with the solution a3 b c d, which is also equal to length 5. And out of these all possible solutions, the minimal possible length is 4. The minimal possible length is 4. Therefore, we need to return A3C3 if this example is considered. So, we need to analyze the algorithm discussed. Let's consider a hypothetical scenario. Let's consider a hypothetical scenario having very long string like this, and here x is a new character getting added to ith location. X is a new character getting added to ith location, and therefore we need to analyze the characters before x. These characters to be analyzed, and the second rule says that if x is same character as I minus 1th character, then increase the frequency count. Okay, that is if x is equal to I minus 1th character, then we will increase the frequency count. So here consider this example. There are 3x and 1 capital X which is at ith position. We compare capital X with the previous character of capital X, that is small x. Therefore, if the characters are same, both the characters are same, then we will increase the frequency count and will return the string x4 here. If the previous condition is false, that is capital X is not equal to small x, then we will not change the frequency count. It will be remained as it is, and the string we need to return is x3 x, which is here the capital X is concatenated to x3. And the third step we follow here is we need to consider 4 variables for solving these problem using DP. We will consider here 4 variables. These are the 4 variables: current index, previous character, frequency of current character, and k. Using these 4 variables, we need to solve the given question using dynamic programming. Yes, as we already discussed the main part of algorithm here. So we will now discuss the problem solving algorithm. Here, for each new character under consideration, there are multiple choices. So one is excluding the character, and one is including the current character. So here the excluding the current character is just escaping the character from I to I plus 1. We are just escaping from one character to other. And here including the current character involves multiple test cases. That is, if previous character is not equal to current character. Okay, let's analyze these test case using these example A, B, C, D up to X, then Z. Here result is a keyword, holds here res is the keyword, holds the result of this string A, B, C, D up to Z X, and X is as X is not equal to previous character. As we are discussing this test case, X is not equal to previous character, we concatenate X with result. That is, now result equal to result becomes, let's make this result, not res. Okay, let it be. Now this becomes res(x). We just concatenate res with x, and length is increased by 1 as we need to pass current frequency count as 1 of x. So here the length will be increased by 1, x is added to the result, and the frequency count of x is now equal to 1. And we will analyze the next test case if previous character is equal to current character. Okay, it's not okay, it is not okay, it's equal to, if previous character is equal to current character. First case is previous character is not equal to current character, and second case is previous character is equal to current character. Here comes number of some more cases to be discussed for this test case. As current frequency here for the first test case for this condition is, as current frequency is considered as current frequency count is considering previous iteration, and result equal to res result x2, as result equal to result x, and now both previous character and current character are equal, we need to update the result as result x2. Here the result is result x, and now the both are equal, both previous character and current character are equal. Will increase the iteration, will increase the frequency count with 1, and will update the result as result x2, and will increase the length by 1. And the second condition in this iteration will be, if there are 9 same repeated characters present already, 9 same repeated characters present already, now we encountered another similar character, therefore will increase length by 1, and result x9 now becomes result x10. That is result x9 now is becoming result x10, and length of the string is increased by 1 because it's a single digit frequency count, it's a double digit frequency count. There is one more test case here we need to consider, and now the third and last test case we need to consider here is, there will be no change in the length, that is length remaining unchanged. This condition is where the length remaining unchanged, that is only result will be changed in this test case. As we encounter another x, now result x2. Result x2 is just replaced with result x3 by increasing the frequency count of x. So we need to follow these steps for solving the given question using DP array. We have built a code. This one, as we mentioned, we use a DP for 4D DP array like that. So I'll pin this code. I'll pin this code in my. I will upload this code in my GitHub, and I will pin the link in the comment. Please check it out. Okay. Let's just submit the code and check whether the code is running good or not. Okay, it's not too fast, but it's okay. Okay, please follow my GitHub account for more solutions like this. Thank you. Please do consider like, share and subscribe.